from the University of Prague, where he founded the Software Testing Intelligence Lab, is going to explain how software can best us at our own job. At least that's what I understood.
Thank you very much. Okay, so actually the title was search-based and learning-based software engineering, but I was trying to, as far as I am in a developer conference, not an academic conference, so it's better to start from some point that is interested for us and to raise that point in this kind of conference. Actually, we are working in our lab on search-based and learning-based software engineering, specifically on search-based software testing. Nowadays, we are publishing a lot of research, a lot of papers, but sadly, less of these papers are going to the industry. So it's good to know what is the problem of these algorithms and what is the problem basically for not taking or not transferring these research into industry. So basically, this era of university industry collaboration takes us back to some long discussion about this two culture, which is the science and humanity during 50s. Nowadays, in the industry, in the university, actually, we have that discussion that they push us to go in the industry just to make our published works are just to collaborate with the industrial companies. Now, we are publishing many papers, as I said, but less of these papers are going to the industry. And probably during 2002, there was a paper, an interesting paper about why less of this research, what are the problems of this research, why they are not going into industry. Basically, we have two missions, actually. We have, in the academia, we have some mission called pure motive, but in the industry, there are missions like translation research and commercialize and profit making. So how to bridge these two areas, how to bridge this wall? Actually, we think in our research institute, we think that we still have a wall. It's true that we are having a lot of companies nowadays doing some AI-based, and they are motivated for these AI solutions. But still, if you look at the, I'm not sure if you are familiar with the research area in the software engineering, we are publishing thousands of papers each month. But less of these papers, even I will show you now in search-based software engineering, we are publishing a lot of papers. And there are a lot of solutions in these papers for the industry. But we cannot find solution for, we cannot find collaboration. Now, probably, in computer science, in general, in software engineering, we are better than other parts, maybe, but still we need to bridge this wall. In software engineering, last year there was a very interesting paper investigating why there are these problems. And there are so many challenges. They investigate so many papers during 2003 until 2016. There was some collaboration between industry and academia in search-based software engineering, basically, but in general in software engineering. But if you look at the amount of published papers, there are many papers, But most of these papers, collaboration papers, are just guidelines, actually. We are giving some guidelines to the industry, but we are not involving into the development process. We are giving some solution, but not really involving in the development process, writing the code for them, giving them algorithms. Still, that connection is weak. Of course, that research is not perfect because most of the companies are having NDA and they don't allow publishing papers. So that's our experience also. But now, our universities are pushing us to go into industry. That's why we have a lot of requests. We are giving a lot of requests to the industry, but the response is not that much. But what is the problem? Actually, there was a book by this guy, the Robert Glass. He mentioned some of these problems, some of these challenges, and also in that research, they mentioned some of these challenges. One of that challenge is the product that we are giving is not interested for the industry, which is basically true. And then we are not understanding the industry needs. And also, we have different interests. Basically, in the academia, we are having publication interest because universities are pushing us to publish a lot of papers, high-impacted papers, because the ranking of the university is going up, but the industry, they are not interested in that, and that's true. And then we don't have resources to give in the industry, and then industry, they don't want to give us resources, and many problems, and also licensing problems when we give some solution to the industry, how they commercialize these solutions. And based on our experience, we have some other challenges, like companies are interested in fast output. We are interested in publication. We have a lot of bureaucracy also, like the lawyers, they take quite a lot of time in the university just to sign some contract. These are really some problems that we are facing also. And on bureaucracy in the industry also, because you don't know really who is the stakeholder for this problem. You send a lot of emails without response, which is kind of weird, but we are trying, but that's not the case. And also, the size of the company makes difference. Big companies are willing to invest into this collaboration, industry, academia collaboration, but small companies not. And then that's the size of the company. Now, there is now a lot of research in search-based software engineering. But as I said, there is a good chance for investing into this search-based software engineering. Search-based software engineering basically is not, maybe you can say AI-based software engineering, but we are not calling that AI-based software engineering because it's not just using this machine learning, because AI is bigger than, as you know, bigger than just machine learning. So that's why just one thing, just one funny thing during one of my meetings with some industrial parts here, we start the meeting. The beginning of the meeting was the manager said, look, I don't think search-based or landing-based software engineering and algorithms will contribute to our work, but let's start the meeting. So basically, that's the end of the meeting because you don't think that algorithm works for you. Now, what is basically search-based software engineering? It's the use of meta-heuristic or heuristic algorithms and optimization algorithms and techniques to find near optimal solution. Now, the idea of this idea has been used quite far before in 1976, but for some reason, this researcher in this paper, he named search-based software engineering. So basically, in 2001, this name initialized. But the technique is back to 1976, maybe. Now, this is the, from the research part, this is the publication and the solution notion of search-based software engineering and search-based software testing. You can see the amount of papers that we are publishing in there, not our research group, but in software engineering community. You can see the amount of research in software testing, also search-based software testing. And then here you can see that it starts with search-based software testing, but now a lot of papers, a lot of research published papers about search-based software engineering in general, not just testing. And you can see also the categorization of the amount of published papers nowadays in search-based software engineering. You can see that a lot of papers published here in search-based software testing, but there are a lot of papers also published, but not compared to that amount in other parts. Now, how it works? Simply, it works like some optimization problem. You have to choose your problem and then choose your optimization technique and decide on your objective function. I will go back to that objective function later. Or we call it sometimes fitness function. And then we search for best solution first, and then search again, update your search space, and then iterate until you will find some good solution. Our experience with particle swarm optimization, for example, it was like a kind of new optimization technique. You have here this search space. You have a lot of good solution, but you search for these solutions. You update your search area based on these equations, and then you will reach, after several iterations, you will reach the best solution. Now, the problem here is your problem must be non-deterministic problem. Actually, there are a lot of problems nowadays, also publishing papers, but they are deterministic. Actually, those algorithms are wrong, to be honest, but they are publishing the papers. Because you have to have some non-deterministic solution. Otherwise, there's no point. You can put some simple counter, some for loop, try all your solutions, and then finally you will get the best one. But this is not the case in search-based software engineering. You have to have like non-deterministic. You don't know really where is your best solution. So that's why you will have this technique, this optimization technique. Now, there are two important components in search-based software engineering in general. The first thing is how you represent your problem, and then the most important thing is the fitness function. What is your fitness function? Based on that fitness function, you will optimize your solution. Without that fitness function, what you are searching for. So that fitness function comes from two things, basically. First is the functional requirement, and the second is the non-functional requirement. We have a lot of research in functional requirement, actually, but in the non-functional requirement, still we need a lot of research. And we need the industrial parts to contribute to that non-functional requirement. Um, what are the publications? What are the applications? Actually, we have a lot of applications. I will go through a few applications that we tried successfully. For example, you have this kind of machine, and then you have many combinations. So we tried this for combinatorial interaction problem, which is really good. And then you can optimize this by just using some optimization algorithm. And then, for example, if you have such a system, and then you want to know which configuration lead to best combination, or what is the best combination that leads to best performance of your system. You don't know. You have to try all the combinations. So if you model this in a simple model, you will end up with this table, and then by some simple probability calculation, you have 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 possibilities, which is kind of a very big possibility. But what if you have many configurations of the system? So you will end up with millions of possibilities. Now, what we are doing here is we are trying to cover all these possibilities with as less as possible test cases, or as less as possible the smallest set of these possibilities. So if you have possibilities like 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, and then you can cover all these like 12 possibilities by just 4 test cases or 4 configurations. So it is really good because I think it's 1 hour. It's 1 hour. Yeah. Now, how we use this, simply, I don't want to go into deep here, since it is developer conference, so there's no need to show equations and those things. But we will generate all the combinations and then use this search base to cover these combinations. And what is the fitness function here? The fitness function here is the coverage. We want to cover as much as possible combination. So that is the fitness function. Now, what are the other applications of this? There are a lot of applications, actually. For example, in the graphical user interface testing, if you have this simple graphical user interface, you have all the possibilities of the events, like going to File, click New, click Open, click all these events, these click events. You can generate all the events using this combinatorial interaction, which is interesting. If you have some configuration window like this, for example, you can model that configuration window into this table. And then from this table, we can generate a lot of interactions and then combine all these interactions together using some search-based algorithm. And then you will get like a very small set but effective set. Now, if you have some other application, like some command line application with different inputs, so you can combine all these inputs together and see where is the fault exactly into your system. And then another thing is you can also take combination of variable combination of the system, not just one combination of the system. Now, also we have tried this as software engineering into the control engineering because, for example, you have some you have some PID, and then you want to optimize the parameters of this PID, then you can use this combinatorial interaction. for just like a plugging into this system, and then that system sends the setting of the PID, and then you can generate the best solution for the PID and feed it back to the system. Also, there are a lot of research nowadays into this feature model in the product line. So if you have a product line and then you have this feature model, then you can basically model this feature model into this table, and you can start from this table in the combinatorial interaction. And also, this is very successful, and we have tried that before. Then now we are collaborating with Red Hat also for this avocado testing framework. By adding this combinatorial interaction plugging into the avocado testing framework. Avocado testing framework is developed by Red Hat. It's a very great framework, and it's used for many testing platforms, actually. So we add this combinatorial interaction into the avocado platform, and generating the avocado will feed the combinatorial interaction about the parameters and values, and then we will generate using some search technique, search-based technique, and then we will feed back the avocado. This is also some kind of modeling, multiplexer modeling of avocado, and then we can start from that model, this model for the generation. Then this is used also for input parameter analysis. Imagine that you have some system and you don't know exactly what are the contribution of these parameters into your system, the contribution of the fault into your system. So you can analyze your parameters and the combination of these parameters just to know the strength of each combination, and then you know the contribution of these combinations into your system for the testing process. There are a lot of applications actually we are working in, like input testing. If you have very large input and then you don't know which kind of input, which kind of sample you take, it's kind of substitution of statistical testing process. And then in model-based testing, if you have such a model having inputs like a kind of class diagram, for example, you can generate test cases based on that from the class diagram. And then you can prioritize your test cases based on the strength of the combination. You have 3 combinations which are very important in 3 combination of the parameters, which are very important in your system. So you can prioritize those test cases which are in which those combinations are involved and put it in the beginning. And then we have this kind of software module clustering also. Nowadays, our software are going up in size in terms of modules, lines of code. So from the maintenance point of view, it's good to have like some grouping of the modules, not just having all the modules together in the software. So what if we group these modules in some clusters, and then if you want to change something, you will go directly into that cluster of the modules, not searching into the entire number of modules in your software. So clustering, we have used that also, and it was very successful. And also you can use it for impact analysis to know which module impacted by your change in the software. So this will maximize the cohesion and minimize the coupling, of course. And then imagine that you have this number of modules by simple mathematical calculation, you will end up with 1.3 billion partitions of these systems, for example. So why not you change these things, grouping them into some small groups using some search base. So the idea is very simple, but it's effective. You can model your modules into the modules inside your software into something called module dependency graph, MDG, something graph like this, and then we will start from this graph, and this graph is generated automatically, of course, and then we use some modularization quality factor, and then this factor is the fitness function. Now, you can see the grouping of your modules without changing the entire of your software, but just grouping them. That's the functional part, functional requirement. But nowadays, the most important thing is the non-functional requirement. How to convert, for example, non-functional requirement into some number. That's challenging for us, actually. And maybe in the industry, we will get some input also from that, because we need to convert, for example, some sort of security into some number, and then using that number in the fitness function, and then generating test cases for that. For example, there is some interesting research here about energy optimization. They take the HTML file of the mobile application using some search-based technique, and then converting the HTML page of the mobile application into some other page which is less energy consuming, which is interesting also. This is not our study. This is a study that has been used, has been published recently. Then another idea is the learning-based. Actually, this learning-based nowadays is very important in the academia also. Learning-based used, for example, in our academic research community into 3 directions. One is the classification, and one is learning from crowd, and then this adaptive feedback system learning. Actually, an interesting research here is I have tried a couple of industrial partners to convince them about this solution, but nobody has the interest for that. But I think this is very interesting, especially for managers, because you will take your bug report and then classify these reports into some clusters based on some crowd learning. So you will classify your bug report one time, and then the algorithm later on, when you learn the algorithm, and then when you give any other report, something like your report before, the algorithm will classify again your bugs. So this is very important, because as a manager, you know where is the problem in your team, and then you will have a better idea about what's going on in your system. So you have like some kind of statistics about the bug reports, and then you know what's going on inside the system, which team is having a lot of bugs and why, and then this is very important, actually, that we are working in now. And finally, we have this recently published paper, which is about software refactoring. They are combining search-based and learning-based engineering together, these algorithms together, and then They published a good paper about this software refactoring by combining both of them. Then finally, what we are doing, actually, an interesting idea for us is to learn from our testing. So you imagine that you have a system under test, and then you want to test this system, then you use some search algorithm to generate the test cases, and then you have this output of the system, the output of your testing, and then why not you learn from this output, and then you modify the set of test cases based on this output. So it's kind of combination of them, and then learning-based software testing. That will be an interesting idea. Finally, what are the challenges for the industry? We don't have to hide everything. So one thing is when you change the optimize, that's my experience actually, but I want to share that experience also. The first thing is changing the optimization technique is not necessarily will change the output of your optimization. So does not really contribute. So basically using any good performed optimization technique will work. There is no need to change the optimization technique. And that's good, actually. And the other thing is the coverage criteria. It's the coverage criteria that makes the solution work and change the solution. And then with the industry, the most problematic thing is the output is not the same every time. So most of the industrial partner, they want the same output every time. So because we are depending on some randomness in these algorithms, it's really hard to have the same output every time. So that's one thing. The other thing is the computation here is very expensive. Actually, in some solution with Red Hat, we find like hundreds of parameters for the input, and then when you input these parameters into the algorithm will take like 1 week just to get the output. So that's also a challenging. The most annoying thing for the industry is the modeling of the system. So it's hard for the industry to figure out how your problem fit into this solution. And then you have to model it. And then most of them, they don't want to model. They don't want to spend time for modeling. And you have to realize that you need this solution. And the final thing is I think we have to find another way in the academia how to communicate with the industry, because publishing papers in the journals and conferences, academic conferences, are not working too much for the industry, because industrial partners are not reading academic papers. And if you publish technical papers, actually technical papers are not having any value in the universities. So there should be some communication. This conference is good to present our solution in the industry. So maybe one or two developer is interested here just to know what are the possibilities for solution here. Thank you very much. If you have any question, just if you want to contact me for, yeah, these are my, yeah, please.
You have discrete inputs and you have an unknown function, or you don't know the properties of the function which does the evaluation of the situation. How can you shortcut or subset the inputs if you don't know the smoothness or whatever of the function?
Well, that's a good question, but actually, that's this challenge. That's the challenge. You have to have like this coverage criteria. You have to give me something to know the quality of the solution that I am getting. Otherwise,
Yeah, but every small step might change it in a fractal way.
not in every system, actually.
Yeah, but then you have to basically describe what kind of systems can be actually solved, and not all of them. And if you're talking about the discrepancy between industry and academia at this point, well, you say, well, there is a system out there which fulfills my nice criteria. Well, we are interested in things like, does it work all the time, regardless of what I put in?
Yeah, but as I said, it's about the modeling or to figure out whether this search-based software engineering is fit to your solution or not. As I said, it's not a magic.
I understand this, and
Yeah.
I appreciate that this is a big problem, and there's a reason why we are not doing more intelligent things.
Yeah.
But just imagine something like what people here are interested in. So the doorbell system or something like this. So if you want to enable the use of, well, making a better coverage analysis, I have to be able to put in every single package in there, every single code in there, and so on, and it just has to work. It cannot just churn there for half a year and say, oh, by the way, I can't go find a solution.
Yeah. So this is kind of maybe shortage of search-based software engineering. But as I said, it's kind of we have to dig into deep the problems. We have to apply these.
So from my perspective, there has to be a nice, basically, interface of feedback method back where we can, where you code up in some way or form the answer to the question, does it apply to the situation, without doing an exhaustive search. So if this is possible, even for a small subset, then it can be used.
Okay, what we are doing now is something that we are integrating this into some code analysis, actually. And then we generate the test cases, basically without any knowledge about the system internal. And then we apply the test cases on the system. And then using this code analysis algorithm that is plugging to our algorithm, we have some kind of information about the system internal, about the code. And then based on that feedback, we regenerate the test cases. So
I understand, so, but how deep of inspection is there? So, for instance, you know AFL.
yeah.
So, AFL goes to great lengths to actually be able to inspect the system under investigation while it is running and getting more details and feedback in that.
Mhm.
So, I think that's the kind of thing you need to do. You need to have much more finding feedback from the system itself.
Exactly. That's what we are doing now. As I said, we are using, for example, code coverage, and then statement coverage, for example, and then we go inside the system to know where these test cases are going inside the system, and then getting feedback from that system to refactor the test cases and refactor the algorithm, the generation algorithm based on that information that we are getting. Any other question?
Less of a question, but perhaps some feedback suggestion. You said that industry doesn't read any scientific papers.
Not 100%, as I said, but I'm speaking about small and medium-sized companies at least.
Exceptions that some people do read scientific
Yeah, of course.
But the trouble is that most of the time, publication of scientific papers ends up in the closed environment of pay-per-view sites, which is pretty expensive most of the time. If you publish papers in sites like archive.org, which is free to access for everybody, make it more democratic, then you might get a larger audience for the output of the scientific research. So I would suggest, I don't know what your managers who care
Actually,
maybe a problem, but this is just feedback.
yeah, that's correct. That's very correct. But to be honest, there is a very big business behind that also, behind this publication.
What's the main problem?
The thing is, we are trying to go into these open access journals, but for example, one journal which is, it depends on the impact factor of the journal also.
It's not about the journal itself, it's a preprint service.
Yeah, but
The most annoying thing is that many scientific research establishments are funded by taxpayers' money. So they're publicly funded, but the output from their research ends up in a private domain, and public don't have open access to those results. They pay at least partly for it.
Often you can find a copy on the author's website, even if it's not official, but
Some of
somewhere
it
it's copied. It's not
Some of
always.
it, not always.
But then it's also not centralized, it's searchable or whatever. So that's the problem. And also this is a problem now. So to some extent you have to see John Mead is some attack at least, where the universities refuse to work with them if you accept it's fine. And they at least put in the contracts that everything which is publicly taxpayer funded also has this possibility. So this is something for every university to negotiate.
yeah, that's
Companies where the budget for buying access to journals would be small relative to what they're spending, is they're not willing to do that.
yeah. So it's kind of a complicated discussion actually about this. I'm not representing all the university around the world, but I'm interested in this. As far as the universities are pushing us to publish, we will publish, but also we are getting bored of publication without getting into the industry, to be honest. So in these conferences, it's good to have that discussion. Otherwise, I can bring a paper and publish and present it here, but you will not be interested. The most important thing for me is this kind of collaboration that we try to establish. Any other question? So thank you very much. Thank you.